But when you actually work through them, you can convert it into a linear form to solve. Okay? So in a problem like this, what we're looking to do is we're looking to multiply or get rid of our variable from the denominator. And the way that we can do that is to multiply everything by the LCD, the least common denominator of all the fractions. So when we look at this first fraction numerically, we need a factor of 11. We also need a factor of q. And then looking at the second one, we need a factor of 15, which we don't already have, a factor of q, which we have, and then the last one, a factor of 15, which we have. So we're looking at it, and here's our three LCD factors. So if I distribute the LCD to each of these individual fractions, each of the terms here, I can get rid of my fractions completely, because here the 11 and the q cancel, so I'm left with the negative 15 from the numerator times the remaining factor up there, which would be a 15. Here the 15 and the q cancel, leaving me minus 9 times the remaining factor would be 11. And that's all equal to the negative 2 times here. The 15 cancels, so the 11 and the q stay. So here is my calculation. So if I wanted to, remember, this system can enter answers as calculations. So if I want to solve for q right here, all I would need to do is divide both sides here by a negative 2 and an 11. So if I divide everything by negative 2 and 11, those cancel. The 11s cancel. I get q is equal to. Okay, so I could enter this as my solution. It'll preview and show me what exactly the calculated value is, okay, but you can just enter that as a calculation. Okay, if you want to do the calculation by hand or on your calculators, you get negative 15 times 15 minus 9 times 11. Again, you can do that in your head if you want. Divide by the entire quantity, negative 2 times 11. Once again, you could just do it in your head, negative 22. Okay, and you get your answer 162 over 11. Okay, and so that would be your solution. The one thing you have to make sure it does not equal, though, due to domain restrictions, is what? What do you know q can never equal? 0. Okay, do we have to worry about that right here? No, it's not equal to 0, so this is your solution.